Hi, everybody. Sorry I'm not there today. I'm going to be at home with a sick 2-year-old. So I wanted to still do our notes with us so that we could move forward in our lessons. Today we're going to do page 35 and 36 for notes, and then 37, 38 is going to be your homework. So please follow along with the notes. This shouldn't take too long, and then you'll have some time to work on your homework. Yesterday in class, we talked about scale copies or similar figures, where we had shapes or triangles that were the same triangle but different sizes. Today we're going to talk about dilation, which we did talk about a little bit yesterday. But a dilation is a transformation that enlarges or shrinks a figure. It makes it bigger or smaller. Okay, it's changing the size. That's really what's going on with the dilation, is we're changing the size. All we end up having to do with this is you take your point, x, y, and you multiply it by k, the scale factor. We saw that kind of yesterday. We did some times 2. We had a triangle that when you looked at it had some centimeter lengths, and when we looked at the second triangle they were doubled. So we're going to be doing the same thing with a scale factor. You take your point and you just multiply it by the scale factor. So for this case we could be multiplying by 2, or if it was making it smaller we could be multiplying by 1/3. So we're going to talk about that stuff. Exercise 1. The scale factor of a dilation is 2. How would you write the rule? So you're going to start at xy, and then you're going to do 2 times x and 2 times y, and those would be your new points. So let's actually try it. Triangle ABC has vertices A, -4, 1, B, -1, 1, and C, -1, 3. Using the rule, write the vertices of the image. All right, so we're going to do a dilation of 2, so times 2, times 2, times 2. And when I write times 2, I'm doing both of them times 2. So -4 times 2 is -8. 1 times 2 is 2. -1 times 2 is -2. 1 times 2 is 2. -1 times 2 is -2. -3 times 2 is -6. And now we'll graph them. So let's start with our given one. -4, 1, A. 1, 2, 3, 4, 1, A. -1, 1, -1, 1, B. -1, 3, C. So here is the original triangle. Nope, sorry, I put the C in the wrong spot. It's supposed to be down. -3, not positive, so 1, 2, 3. Here's C. Here's the original triangle. That was my fault. Okay, so anyways, not there. So then we're going to graph our primes. So -8, 2. So -8, 2 is A prime. -2, 2 is B prime. And -2, 6 is C prime. And then we connect it, and we will get a triangle that is twice as big. So if we look at our original side length of AB, 1, 2, 3 units, and A prime to B prime, 1, 2, 3, 4, 5, 6 units, we notice that it got twice as long. Look at your original B to C, 1, 2, 3, 4 units, and then B prime to C prime, 1, 2, 3, 4, 5, 6, 7, 8 units. Again, times 2. So this dilation with a scale factor of 2 was an enlargement. All right, let's go down to exercise 2. This time we're going to use a scale factor of 1/2. So we're going to take all of our original points and we're going to multiply them by 1/2. So let's first graph. I'm going to graph my originals. P is -2, 4. So -2, 4. P. Q is 4, 4, 4, 4. Q. R is 4, -2, 4, -2 is R. And S is -4, -4. S. So we'll connect this. Okay. So there's the shape. Not a square, not a trapezoid, not a parallelogram, just a quadrilateral, just a four-sided figure. And now we're going to find our points of P prime. So -2 times 1/2 is -1. 4 times 1/2 is 2. 4 times 1/2 is 2. 4 times 1/2 is 2. 4 times 1/2 again is 2. -2 times 1/2, -1. And -4 times 1/2 is -2. -4 times 1/2, -2. And then let's graph that. -1, 2, -1, 2. That's P prime. 2, 2, 2, 2. That's Q prime. 2, -1, 2, -1. That's R prime. And then -2, -2. That's S prime. Okay, so again, this line's not as straight as I want it to be. It's fine. But again, we've noticed that this made it smaller. So this dilation of a scale factor of 1/2 was a shrink. It got smaller. Another word for shrink, reduction. So you might see reduction as well. Okay, so that's really what dilations is you get the scale factor and then you multiply the points by the scale factor. So it's really kind of simple to do it on a coordinate plane. You just take the points, each one, and multiply them by 2 in this case. Take these points and multiply each one by 1/2. So let's go to page 36. There are some rules up here, really important ones to help us. In general, when doing a dilation, if the scale factor of a dilation is greater than 1, the figure becomes blank. This is an enlargement. Larger, bigger, whatever word we want to kind of use there. So the figure is going to grow. It's going to get bigger. It's going to get larger. This is an enlargement. Greater than 1 grows the figure. It gets larger. If the scale factor is between 0 and 1, so less than 1, the figure becomes smaller. This is a reduction, or it shrinks. So between 0 and 1 would be something like 1/2, 1/4, 1/3, 2/5. All of those types of things would make the shape smaller. So this is talking about congruence and things like that down here. Our rigid transformations, our rigid motions, reflection, rotation, translation. All three of those make congruent images. Okay, so that's a really big point here for us. are rigid motions. Those three transformations make congruent images. Dilations produce an image that is the same shape, but a different size. And the fact that it is a different size means it's not congruent. A dilation is similar, which was our lesson yesterday. A dilation is similar. It does not create a congruent shape. So a dilation is not a rigid motion. The rigid motion has to make congruent shapes. So a rigid motion is a reflection, rotation, translation. Those make congruent shapes. Dilations make similar shapes. Okay, I'll do the first one. I'll start with the homework for you, and then your homework will be, so your homework is 37 through 38 all. All right. What are the coordinates of triangle PQR after a dilation of 2/3? All right, so what I think I should do is figure out what is P, what is Q, what is R. If I can find the original ones, then I can just multiply by 2/3. Q is left and right, 0, up 6. So 0, 6. P is -6, 1, 2, 3, up 3. So -6, 3. R is +6, up 6. So 6, 6. And what I'm going to do for each part is multiply by 2/3. So I'm going to do -6 times 2/3, and I'm going to get -4. So P prime will be -4. And then I'm going to do 3 times 2/3 and get 2. So P prime will be at -4, 2. -4, 2. P prime. I don't actually think you have to graph it. I'm just doing it to help you visualize what's going on. 0 for Q, 0 times 2/3 is still 0, so Q prime will still be 0. But then I'm doing 6 times 2/3, and that is 4. So Q prime will be 0 for Q prime. And S prime will be 6 times 2/3, 4, and 6 times 2/3, 4. So 4, 4 for R, not S, sorry, R prime. So there it is. All right, so then I got to find it. -4, 2, good, good. So these two are out. They did not have P prime correct. 0, 4, 4, 0, no, this one. Oh, draw the image. So I did have to do it. Nice. All right, so page 36 is done. 37 and 38 is your homework. Hopefully this helps, and I will see you on Monday. Have a good weekend.